Hi, welcome to the video solution for Edexcel IAL mathematics. This is M1 paper, Gen 2014, part 1. So let's start. Question number 1. A truck P of mass 2m is moving with a speed u on a smooth straight horizontal rails. It collides directly with another truck Q of mass 3m, which is moving with the speed 4u in the opposite direction on the same rails. The trucks join so that immediately after the collision they move together. By modeling the trucks as particles, find the speed of trucks immediately after the collision. So we have a situation of two trucks moving in opposite direction. So truck P has mass 2m and it is moving with the velocity of u. Let's suppose this is moving rightward, and we have another truck Q which has a greater mass than P, and also it is moving with the greater velocity than P. So it has a velocity 4u. Clearly Q has a greater momentum. Now both the particles collide, and after collide they join, and after joining they move together. Clearly if you see that particle Q is heavier than particle P, also it has greater velocity. So after collision it is clear that both the particles, when they join, they will be moving together leftward with some velocity v. And it's all about collision and momentum. So when we apply law of conservation of momentum, remember you need to take care of the direction of motion. It's my habit that the particle moving rightward, I take it direction as positive, and the leftward I take negative, but you can choose vice versa. That means momentum of particle P for me is positive, and particle Q, the momentum I'm going to take negative, as well as after collision the particles are moving leftward, so it will be the negative momentum. So you apply law of conservation of momentum before collision. So before collision, momentum of particle P, which is 2mu minus momentum of particle Q, which is 4 times 3, 12 mu, equal to momentum after collision and the both particle after joining moving leftward. So the total mass will be 5m moving with velocity v but in opposite direction, so minus 5mv. So the answer will be minus 10 mu is equal to minus 5mv. So 5 and 10 minus gone, gone, so v is equal to 2u. So both will be moving with the speed of 2u. Part B, the magnitude of the impulse exerted on P by Q in the collision. So impulse on P is IP is change in momentum of P. So you can say that mass of the particle P, which is 2m, and change in velocity. So velocity is changing from u to v. V is equal to 2u or minus 2u. So final velocity is minus 2u. Initial velocity minus initial velocity was u, so overall answer will be minus 2u and minus u. 3u multiplied by 2, so minus 6mu. This is impulse with direction, but we are interested only in magnitude, so impulse on P would be 6mu. That's how you can figure out the impulse. Question number 2. A particle P is moving with a velocity 2i minus 3j meter per second. Find the speed of P. So velocity vector is given, speed is the magnitude of that velocity vector. So speed of P, so v, you can say Vp magnitude would be equal to 2 squared plus minus 3 squared root, and when you solve this, so the speed will be 4 plus 9 13, so root 13 meter second inverse. That would be the magnitude of the velocity or speed of the particle p. The particle p passes through the point A, and 4 seconds later passes through the point with the position vector I minus 4j. Find the position vector of A. Okay, the situation is the particle p, if you draw the situation, so this is your coordinate axis, you can plot, and with respect to a region, the particle p at t equal to 0, there was a point A, and at t equal to 0, but after 4 seconds the particle is passing through the point with the position vector of I minus 4j. If you see I minus 4j, this is a position vector after 4 seconds, so I minus 4j you can visualize 1 and minus 4, something like this. It's just, so this is your new position vector after 4 seconds, and I'm going to call this position vector as R after 4 seconds, and I minus 4j. Clearly I just assumed that the particle was at A because it was not given. That's what we need to find. So we needed to find this position vector RA at t equal to 0. Now if you see the diagram, during this 4 seconds the particle was coming in that direction, so you can think that now particles coming from A to that point, let's call it P. So this AP is basically change in the position delta R, and which is in fact V into T. And you know that you have a relation between position vector at t equal to 0 and position vector at some time t. So R position vector after time t is R naught plus Vt, and R naught is a position vector at t equal to 0. In this case this is Ra, so R is equal to Ra plus Vt. So Ra is equal to R minus Vt, and R is I minus 4j. Minus 4 is the velocity vector, which is 2I minus 3j times of t in 4 seconds. And now you can multiply this 4 and separate I and j component, and if you do that, Ra would be equal to, so 1 minus 8. That means it will be minus 7I minus 4 and plus 12. So minus 4 plus 12, it will be 8j. This is the position vector of point A at t equal to 0, or the beginning of the situation. Question number 3. A beam has a length 15 meter and a mass 25 kg. The beam is smoothly supported at a point P where AP is equal to 8 meter. A man of mass 100 kg stands on the beam at a distance of 2 meter from A. Another man stands on the beam at a distance of 1 meter from B. The beam is modeled as a non-uniform rod. Okay, this is non-uniform rod, and the man are modeled as a particles. The beam is in equilibrium in a horizontal position with the reaction on the beam at P having magnitude 2009. Find the distance of center of mass of the beam from A. So you can think that you have a beam AB. This is A and this is B. The total length of the beam is 15 meter, and you have a support at P which is AP equal to 8 meters. So this is 7.5. That means it will be somewhere here. This is support P. And then a man of mass 100 kg stands on a beam at a distance of 2 meters from A. So a man is standing somewhere here. This is man, mass 100 kg. That means weight is acting down with 100 G. And another man is standing 1 meter from B at the other side. So this is B, 1 meter from here. This is another man of mass M. I don't know the mass, so let's see. This is the point. Another man stands. So let's call this point as C. The second man is standing at point C. The weight of the man, mass is not given. Let's suppose it is W. And this is the situation where AP, so you know that this distance from A to P, this distance is 8. And this distance is 2. This is 1 meter, and the rod is non-uniform, so the center of mass or the center of gravity or the weight of the rod cannot act at the center of the rod. And according to the situation, because P is at 8 meter from A, so center of mass should be between P and B, so that the rod will be in equilibrium. Because if center of gravity you take between A and P, so you would have a greater momentum on the anti-clockwise direction. So the center of mass, I'm assuming here, this is center of gravity, and the weight is acting is 25 G, and the center of gravity is X meter from A. This is X. So now we need to find X. This is our question mark. So if you see the situation, all the forces, there is a resultant force, or sorry, normal force acting at P, which is 2009 Newton. Now, if you see the whole situation, you have just one unknown that for the meantime is difficult to figure out for the meantime, which is W. And taking this advantage, I'm taking C as a pivot, because if C is a pivot, then W is gone from our equation. We don't need to worry about the value of W. Rest of the forces we know the values, so we can easily figure out the X. So let's say moment about C. So now first you need to figure out if C is your pivot, then how many moment clockwise and anti-clockwise will be acting. So if you see C as a pivot, this 25G is going to produce moment anti-clockwise, so the 100G. And this 2009 is going to produce clockwise moment. And this fact we can use easily. Now let's see. So you can say that 25G, which is the force or weight of the plank, producing anti-clockwise movement, and we need that distance from the pivot. Clearly, this distance, we know that this is X and this is 1. So that distance would be equal to 14 minus X. 14 minus X. So 25G times 14 minus X plus 100G times of distance, and from 100 till pivot. So you know that this is 2 and this is 1, so total is 15. So 2 and 1, 3 are gone. So from 100 till C it will be 12, equal to clockwise moment, which is due to 2009. So 2009 times the distance from normal force to the to the pivot. This is 1 and this is 8. So this is 8 and 1 is less, so you know that this is 6, so it will be 6. And now the only unknown in this equation is x. You just multiply these values and you simplify for x. If you do that, then x will be equal to 12.8 meter, or you round it off, you can say 13 meter. So this is the distance from A, distance of the mass, center of mass from A. So x is equal to 12.8 meter. Question number 4. A fixed rough plane is inclined to the horizontal at an angle alpha, where alpha tangent alpha is 3/4. A small box of mass m is at rest on the plane. A force of magnitude kmg, where k is a constant, is applied to the box. The line of action of the force is at an angle of alpha to the line of greatest slope of the plane through the box, as shown in the figure, and lies in the same vertical plane. The coefficient of friction between the box is mu. The box is on the point of slipping up. Okay, key point. By modeling the box as a particle, find the k in terms of mu. Okay, so you know that you will have to first visualize the forces. This is inclined plane and angle alpha is given, and fact is tangent alpha equal to 3/4, and this is tangent. That means this is your opposite, this is your adjacent. So your hypotenuse would be equal to 5. That means sine alpha would be equal to 3/5 and cos alpha would be equal to 4/5. These are the values that we are going to need in future after resolving forces. Now this is inclined plane. You know that you have forces acting. So one force is a contact force acting up the plane 90 degrees. So this is normal reaction force R, and you have a perpendicular component to the plane, component of the weight, which is mass is m. So this is mg cos of alpha, and down the plane we have another component of weight, which is mg sin alpha. And as the particle is at the point of slipping up the plane, that means we have friction acting down, F. Moreover, other than these components, we know that kmg is making some angle alpha, so we can resolve alpha into its kmg into its component parallel and perpendicular to the plane. So you can think so. Let's see. So you say that this is kmg cos alpha, because adjacent component, and this is kmg sin alpha. Now you write the system of equation. So first system is resolving forces parallel to the plane. So resolving so you need to resolve forces first parallel and perpendicular to the plane. So resolving forces perpendicular to the plane, let's suppose in that direction, and you know that you have three forces acting are kmg sin alpha and mg cos alpha. So you say that kmg sin alpha is acting up the plane, so you can write it as kmg sin alpha plus r is equal to mg cos of alpha. And then if you wish, you can substitute the value for sin alpha and the cos alpha, and then you can say that kmg sin alpha is 3/5, so 3 kmg by 5 plus r is equal to mg cos alpha. Cos alpha is 4 by 5, so 4 mg by 5. And because we need to find k, so it's good to rearrange the equation so that we have mg on one side and r on the other side. So you send this 4 mg on the other side and r on the right hand side, so you can rewrite this equation as 3k mg upon 5 minus 4 mg upon 5 is equal to minus r. Let's call it equation number 1. Now you can resolve forces parallel to the plane. So resolve forces parallel to the plane, and you know that parallel to the plane you have 3 forces acting, 2 forces acting down, 1 is acting up. So you can say that you have kmg cos of alpha is equal to mg sin alpha plus f, and you can substitute value of cos alpha, sin alpha and f here. So kmg cos alpha is 4 by 5, so you can say that 4 by 5 kmg cos alpha, and is equal to mg sin alpha. So mg sin alpha is 3 by 5, so 3 mg by 5 plus f is mu r, and then again you can rearrange this equation so that you can send 3 mg on the other side. So you have 4k mg upon 5 minus 3 mg upon 5 is equal to mu r. Equation number 2. Clearly we need to find the relation between k and u only, and we have equation in terms of k, u and r, so we need to get rid of r. And how can we do that? If you see closely, you can think of, or you can think that if you multiply this whole equation 1 by mu, and after multiplying by mu, on the right hand side of this equation you have a minus mu r, so you can add 1 and 2 so that you can cancel mu r and mu r. So you can multiply this equation by mu and then add 1 and 2. So if you multiply equation 1, so 1 implies that 3k mg mu upon 5 minus 4 mg mu upon 5 is equal to minus mu r. And then you can add equation number 2 underneath. Equation 2 is 4 kmg upon 5 minus 3 mg upon 5 is equal to mu r. And if you add, so you can cancel minus mu r and mu r, and then what else left here? So from here, if you see, you have some common terms here. You have a k common, you have m common, g common, and 5 common. So you can take k mg upon 5, and inside the bracket you have 3 mu plus 4 from these first term, and then Here you can take minus mg upon 5 common. Mg upon 5, inside the bracket you have mg upon mu plus 3, 4 mu plus 3, so 4 mu plus 3 equal to 0. Now you can send this term on the other side, so you can, let's see if I can write here, kmg upon 5 into 3 mu plus 4 equal, on the right hand side send this term, so mg upon 5 4 mu plus 3, 4 mu plus 3. So G cancel, 5 cancel, so you have a k times of 3 mu plus 4, and on the other side you have a 4 mu plus 3, and you can figure out k from here. So if you find k and send 3 mu plus 4 on the other side, so k would be equal to 4 mu plus 3 divided by 3 mu plus 4. So 3 plus 4 mu divided by 3 mu plus 4, this is the value of k in terms of mu. I'm sorry about this messy work, because I just want to do, I don't want to erase any equation. I hope you understand. Thank you very much for this video, and have a nice time.